Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject short range wireless communication. We're going to see the working of digital receivers. When we say digital receivers, it can be also called as software defined radio. We will see the complete working of digital receiver or software defined radio in this particular video. And before this, we already seen the working of various receiver like direct conversion receiver, super heterodyne receiver, TRF receivers, and basics about various RF receivers, right? And receiver parameters as well. I would recommend you people to go and watch those videos first so that you can understand the basics of the receiver, and then you can watch this particular video, which will be very easy to understand. And to start with software defined radio, I would like to set up a clear expectation here. What is meant by digital receiver first, right? So far we have seen different RF receivers. What is the difference between the RF receiver and the digital receiver? Everything is going to be same. That is, we are going to just receive the signal and then you're going to down convert it to a different frequency and then you're going to detect the original signal and then you're going to use that original signal, right? The same operation. But here, when we say digital receiver or when we say software defined radio, we will use software platforms for demodulation, for modulation, for filtering, so that we can achieve a better performance, an improved performance. So basically, if we say digital receivers, we will use software platforms, softwares for demodulation, modulation, for changing the carrier frequencies, for filtering methods, for all those things, right? So now we'll see the working of a digital receiver. And as I said, digital receiver can also be called a software defined radio, where we will use digital signal processing components, uh, which is predetermined, that is, which performance characteristics is determined by the software. And the working is completely very similar to super heterodyne, whereas the mixing and IF filtering will be done by the analog to digital converter and digital filters. And these filters, digital filters, are not predominantly used right now in short range devices or short range frequencies. That's because of more cost is very high, right? But in future, right, as the performance of the wireless communication requirement is increasing day by day, right? Soon we will use this digital receivers even in short range devices or short range frequencies, right? Coming to the working of this digital receiver, we will see digital receiver and as well as transmitter here. Like it is very similar to the super heterodyne receiver. So you can see here the transmitted signal will be received by the antenna and then it is amplified by the low noise amplifier. So it will amplify the received signal and then it is sent to the mixer, where the mixer, it will mix the received RF signal and the local oscillator signal to produce the IF signal, which is very similar to super heterodyne receiver, right? And this IF signal is amplified, and then here it is, after amplification, it is sent to ADC, analog to digital converter. Here, the analog digital converter replaces the second mixer in super heterodyne receiver, right? And this analog to digital conversion, after the signal is converted from analog to digital, here it is sent to the DSP platforms, that is a digital demodulation and filtering. Whereas here, the filtering, demodulation, IF filtering, everything will be done by using this DSP software, right? And similarly, at the transmitting side, the digital transmitter, what we will do is we will use direct digital synthesizer, right? What direct digital synthesizer, where we will use a softwares, right? Digital software where it will convert this DDS will convert the received signal, right, to digital words, and that digital words will be converted to analog signal by using DAC. And when we say DDS, this will be implemented using software, whereas here all the modulation, any type of modulation can be used, and similarly the carrier frequency, amplitude, modulation, anything can be changed, right? Any modulation technique can be changed because we are going to use software, and very importantly, any modulation can be used without changing the hardware. That is the very important advantage of digital receiver, right? And this DDS will send the digital signal, where that will be converted to analog signal by DAC, and then it is sent to mixer, where the mixer will upconvert by using a local oscillator signal, and that signal will be amplified and then transmitted. And once again, you know the working of the receiver, right? So this is the complete working of digital receiver and transmitter, right? And whatever I said, that is what I explained here. As I said, the phase, frequency, and amplified version of the carrier function, like implemented by the software, and any modulation can be used without the change in hardware. And similarly, DDS convert to an analog signal, right? The digital output of DDS can convert it to an analog signal by using DAC, and then we will use local oscillator and mixer signal, right, which is up converted and then transmitted, which is very similar to super heterodyne principle, right? And here you got to understand that as in the receiving side, we perform demodulation, IF filtering, everything using software, and in the transmitting side, we will perform all the modulation and carrier frequency changes. Everything will be done using software, right? That is the very important advantage of uh, digital receiver. You can see here by performing modulation and demodulation software and also filtering, greater flexibility is achieved and high performance stability can be achieved. Elimination of many hardware components reduces the cost while giving high communication efficiency and bandwidth, utilization, and error correction. These are the advantages of digital receivers, right? So today what we have seen is we have seen the working of digital receivers, right? I believe this video will be very useful for you. Thank you, my dear students.